Chapter 7.2, multiplying powers with the same base. So you can write a product of powers with the same base, such as 3 to the fourth and 3 squared, using one exponent. So remember, if I have 3 to the fourth, the 3 is the base. As long as the base is the same, you can combine exponents. So 3 to the fourth times 3 squared is going to equal 3 to the sixth power. You're going to add the exponents. So when you are multiplying two bases together, add the exponents. So why does this work? So if I have 3 to the fourth, which is 3 times 3 times 3 times 3, and I multiply that times 3 squared, which is 3 times 3, altogether I am multiplying 1, 2, 3, 4, 5, 6 3's together, which gets me 3 to the sixth power. So let's take a look at example 1. What is each expression written using each base only once? So here I have the base of 12 to the fourth and the base of 12 to the third. So 12 to the fourth times 12 to the third equals 12 to the 4 plus 3, or 12 to the seventh power. Here at example B, I have a base of -5. And again, notice these parentheses. It's a -5 to the -2 power times -5 to the seventh power. Well, that's going to equal -5, again in parentheses, to the -2 plus 7 power, which equals -5 to the fifth power, because -2 plus 7 is 5. Okay, so even if you have a negative exponent here, because you have the same base and you are adding them together, you're going to add. As long as your final exponent is positive, then you do not need to take the reciprocal. Okay, take the reciprocal at the end if you need to. Always simplify first. So example 2, what is the simplified form of each expression? So here I have 4z to the fifth times 9z to the -12. So 4 and 9 are my coefficients. They can get multiplied together. So I'm going to group them. 4 times 9 times my z's. Z to the fifth times z to the -12th. Well, 4 times 9 is 36. Z to the fifth times z to the -12th. 5 plus -12 is -7. So z to the -7. Now that I've simplified and I have a negative exponent, now I need to put it into the reciprocal. So I will have 36 over z to the seventh power as my final simplified answer here. Okay, let's take a look at part B. So we have 2a times 9b to the fourth times 3a squared. So the first thing I'm going to do is take all of my coefficients. So 2 times 9 times 3. And then I'm going to group my like variables. So a from here times a squared from over here, and then times, times b to the fourth. So 2 times 3 is 6, 6 times 9 is 54. A times a squared, this is like a to the first power, so I'm going to add a to the first plus a to the second equals a cubed, and then b to the fourth. It's all by itself over there. So remember, when you have just a variable by itself, its exponent is 1, and you still need to add it to whatever other variables, whatever basis exponent you have. Okay? All right, let's take a look at example 3. At 20 degrees Celsius, 1 cubic meter of water has a mass of about 9.98 times 10 to the 5th grams. Each gram of water contains about 3.34 times 10 to the 22nd molecules of water. About how many molecules of water does the droplet of water shown below contain? So the volume of this droplet is 1.13 times 10 to the negative 2nd meters squared. So my molecule of water, I'm going to multiply the volume of my molecule. So we'll do it down here. 1.13 times 10 to the negative 7th meters cubed. And we are going to multiply or divide it by the number of the mass per cubic meter. So 1 cubic meter is 9.98 times 10 to the 5th grams. My meters cubed get canceled out. And then I need to know the number of molecules per gram. So in 1 gram, I have 3.34 times 10 to the 22nd molecules. So the units I will be left with will be molecules. Okay, there are my units. So I'm going to take 1.13 times, I'm going to use the x, 9.98 times 3.34. Those are all the bases. And now I'm going to take the scientific notations. The 10 to the negative 7th from over here times 10 to the 5th from here times 10 to the 22nd from here. So if I multiply these three numbers together, I'm going to get 37.7 times 10 to the negative 7 plus 5 is negative 2. Negative 2 plus 22 is 20. However, scientific notation has to be greater than 1, but less than 10. I have 37.7, so I need to move this decimal one place over, which means I'm going to add 1 to my exponent. So there are 3.77 times 10 to the 21st molecules. Okay? All right. Exponents can also be expressed as fractions. Fractional exponents are called rational exponents. Recall that 3 squared means 3 times 3, which equals 9. You can rewrite the same expression using rational exponents, 9 to the 1/2. The equation 9 to the 1/2 equals b indicates that b is the positive number that when multiplied by itself equals 9. So 9 to the 1/2 power equals 3, since 3 times 3 equals 9. So what the heck does that mean? So 9 to the 1/2 power, this 2 right here means that this is going to be my exponent. let's make it a 2. There we go. So this 1/2 means that I want whatever number I'm going to square will equal 9. So it's like the inverse or the opposite. So 9 to the 1/2 power is the same as 3 squared. What number squared equals 9? So you can think of the exponent doesn't actually go there, but I want you to kind of imagine. I'll change the color so that, okay, you can kind of imagine this 2 here. 3 squared equals 9. What number squared equals 9? 3. So let's take a stab at this. Simplify the expression 81 to the 1/4 power. So 81 to the 1/4 power equals some number. So what I want to know is what number, when I multiply it 4 times, will equal 81. Well, you can use a calculator. There's a button that looks like this. Okay, it is a second function. So if you type in 4 and then that button, that's an X, and then 81, it will tell you what the 4th root of 81 is. And I will tell you that the 4th root is 3. Because 3 times 3 is 9. 9 times 3 is 27. And 27 times 3 is 81. So in example 5, we're going to take that to the next level. You can also have expressions like 9 to the 3/2, that's what that says. 9 to the 3/2, which means 9 to the 1/2 times 9 to the 1/2 times 9 to the 1/2. Consider each individually. Because 9 to the 1/2 equals 3, you know that 9 to the 1/2 times 9 to the 1/2 times 9 to the 1/2 equals 3 times 3 times 3, which is 27. So 64 to the 3/2. 64 to the 3/2. Okay, that half means I want to know what is the square root of 64. Because I'm going to have 64 to the 1/2 times 64 to the 1/2 times 64 to the 1/2. Well, the square root of 64 is 8. So I'm going to replace 64 to the 1/2 equals 8. So I have 8 times 8 times 8. 8 times 8 is 64 times 8, which equals 512. So 64 to the 3/2 power equals 512. Okay, one more. Multiplying powers with the same base. So even though the exponents on these bases might be fractions, the same rules apply. You still add them together. So simplify 2a to the 2/3 plus times 3b to the 1/4 times a to the 1/3 times 5b to the 1/2. So I'm going to again start by writing the original equation. 2a to the 2/3 times, should be a 3, 3b to the 1/4 times a to the 1/3 times 5b to the 1/2. So I'm going to start by taking my coefficients. 2 times 5. And then my a's. A to the 2/3 times a to the 1/3. And then my b's. B to the 1/4 times b to the 1/2. 5 times 2 is 10. A to the 2/3 times a to the 1/3 is a to the 2/3 plus 1/3. well, 2/3 plus 1/3 is 1, and a to the first power is just a. Then I have b to the 1/4 plus 1/2. Well, 1/4 plus 1/2 is 1/4 plus 2/4 is 3/4. So I'm going to then have b to the 3/4 power. And that is as simplified as we can get. Okay, that's it for examples today. Complete those got it, and I'll answer questions the next time I see you.